Hi, my name is Alexandra. I'm a graduate student at the University of Illinois, and today I'm going to be talking about the efficacy of attractants for detecting Eastern Spotted Skunks and our experimental approach to testing that. So I'm not going to talk about the history of Eastern Spotted Skunks or the decline, because I think everybody here knows that story pretty well already, but I will say that they are very hard to monitor simply because their detections are so low. Their low abundance and cryptic nature just make it very difficult. From the studies that we looked at in our literature review, which I will get to in a second, detections averaged about 2 detections per 100 trap nights, and that number got as low as 0.07 detections per 100 trap nights. So very hard to get a good sample size with that. And I think this is why a lot of studies use attractants to increase their detections. An attractant can be either a lure, which is visual, olfactory, or auditory, or a bait, which is edible and the animal can actually eat. And really, these are just meant to bring the animal into whatever kind of trap you're using, and if it's a camera trap, to bring them in front of the camera rather than passing behind it where they may not be detected. It also keeps them there longer, which lets you get better pictures, more body angles, and it's better for detecting individuals and species. So before we started our study, we did a literature review of all papers that used an attractant for Eastern Spotted Skunks. We found 15 studies since the year 2000. 2 of those studies actually used an attractant for a different species, but they incidentally captured Eastern Spotted Skunks, so we included them in our review since they clearly were also effective for the Eastern Spotted Skunk. So you can see the breakdown here of the different attractant types. Canned fish, usually sardines, was the most common, but there were also several commercial lures, cat food, various forms of fruit, and a couple studies that used meat. One I think just used chicken, but another one used deer carcasses, and actually it was pretty successful in attracting Eastern Spotted Skunks. As you can tell, these numbers don't actually add up to 15. That's because a lot of studies used more than one kind of attractant in their study. It's possible that using some combination is more effective than one alone. I don't know that for sure. And then all of these studies either used live traps, track plates, or camera traps. So in our literature review, most of the studies were using attractants just to increase detections, but we're testing something totally separate. But there were 2 studies that actually did compare monitoring methods. The first one was Hackett et al. 2007, which compared trapping methods of live traps, camera traps, and track plates. I believe they found track plates to be some of the more effective, and they used sardines with all 3 of those. They also found that they didn't catch any skunks during the summer and suggest in that paper that perhaps monitoring in colder months is better. And the second paper was Eng and Jakowski 2019, which actually did compare attractants, but used a control of sardines. So they looked at cherry oil and sardines, Caven's Gusto and sardines, and then a control of just sardines. I believe Caven's Gusto was effective and the cherry oil was not. But there have not been any studies that have compared attractants to a true control of no attractant. Again, I think a lot of that has to do with those very low detections and difficulty in getting a good sample size. So because of this, we decided to test the efficacy of 3 attractants for both increasing detections and reducing latency to detection of Eastern Spotted Skunks with camera traps. We used sardines because they were the most commonly used attractant for spotted skunks. Fatty acid tablets because while they're not very commonly used for skunks, they're common for other mesocarnivores, and so it's possible that they would also be effective for skunks. And then a wild boar carcass because of the success of that one study, I believe it was Thorne et al. 2017, that used a deer carcass and had high success in detecting Eastern Spotted Skunks. And then we compared all of those to a true control of no attractant at all. And the sardines and the fatty acid tablets we used as lures, scent lures, where they were hung in a tree and were not accessible for consumption. And then the wild boar carcass was a bait where we put it on the ground and the skunks could eat it. We also decided to examine the seasonal and daily activity patterns of the skunks and basically look at if those were affected by using an attractant at all, to see if that would bias data. So this is our study area. It's Fort Hood in Central Texas, and it's used pretty heavily by the military for training. It also allows recreation, hunting, fishing, those sorts of things. But because it's protected from surrounding development and agriculture, it's become a sort of de facto bioreserve. There's also staff, biological staff there that do a lot of management and monitoring and really work to preserve the biodiversity there. So we put our camera traps out in the spring and winter of 2018 through 2020. For the 2 scent lures and the control, we put out 140 camera stations every year or each year and left them out for about 39 trap nights. And then for the wild pig, we put 16 carcasses out, which are in the blue stars there on the map, in just 2020. And if you're wondering why we don't have any cameras in the middle of Fort Hood, that's because that's where the military does their live fire training, and we were very much not allowed in that area. So for the scent lures, the sardines and the fatty acid tablets, as well as the control, we randomly assigned each of those attractants to a camera location. Those locations stayed consistent within a year, but were different between years. And then we hung them in a mesh bag across the trail from the camera trap and refreshed them about every 2 weeks. These lures were refreshed 2 to 3 times depending on the year, and those camera traps were set to take 10 photos every time they were triggered. For the wild boar carcass, we either put them on the ground after the lures had been removed from a grid, or more than 6 weeks before the lures were deployed, just to try to avoid biasing that lure data. These carcasses were placed out for 2 weeks total. We did not refresh them, and those cameras took 1-minute videos. And can I say, I know fieldwork is never glamorous, but this is some of the smelliest fieldwork I've ever done. I thought nothing could smell worse than those fatty acid tablets, but it turns out boar carcasses are definitely worse. So to test our results, we only considered detections that were at least 30 minutes apart, just to try to reduce pseudo-replication and avoid overcounting individuals. We also looked at detections over a session, which was that 2-week period from when the attractant was deployed to the time we either collected it or refreshed it. And just to give you an idea, the 2 scent lures and the control had 85 to 86 sessions each, and then the wild boar carcass had 16 sessions. We then used a binomial generalized linear model to look at detection versus non-detection over those 2-week sessions between attractants. We also use this model to compare detections between months to look at the seasonality of detections. And then we further included the length of each session in that model just to account for the fact that not every session was exactly 2 weeks. We used a Welch's t-test to compare latency detection, which was the number of days until the first skunk was detected at each camera. And then we used kernel density to look at daily temporal activity, and we compared that temporal activity between attractants and the control using the activity package in R. So these are our detection results. We had 89 total independent detections of Eastern Spotted Skunks over about 10,000 trap nights. Again, those are more than 30 minutes apart. And I think that just goes to reiterate my point about how difficult they are to detect, how low detections are, etc. And then this graph is showing you the proportion of cameras that a skunk was detected at with each attractant in the blue and on the left axis, and then the number of detections per 100 trap nights in the green and the right axis. The bars represent standard error. So you can see from this that wild boar carcass was by far the most effective attractant. Wild boar carcass had more than 5 times the number of detections as the control and more than 2 times that of sardines. Sardines were also significantly better than the control. They had about 2 times as many detections as the control. And then fatty acid tablets were not significantly different than the control. And I would like to just point out that wild boar carcass and sardines have the same proportion of cameras that skunks were detected at, but wild boar carcass has significantly higher detections per 100 trap nights. This could just be due to repeat visits. I think once a skunk realizes that that carcass is there and that they can eat it, they're likely to come back again and again. So it's possible that that explains some of that pattern. These are our latency to detection results. Wild boar carcass was the only attractant to significantly decrease latency to detection. It was about 6 days until we detected a skunk with the wild boar carcass and about 13 to 17 days with any of the other 3. Again, none of the other 3 were significantly different from each other. And these bars represent 95% confidence intervals. So these are our seasonal detection results. This graph is showing the detection probability based on our binomial model, with the bars representing standard error. So our highest detections were actually in the spring, which is pretty warm in Texas. By March and April, it's getting into the 80s and 90s pretty frequently. And our lowest detections were actually in the colder months in the winter. February, March, and April all had significantly higher detections than December. January had pretty low detections too, but it wasn't significantly different from the others. And this pattern could have something to do with breeding season. These skunks breed March, April, and I believe Les Meister et al. 2009 found that their home range size increases significantly during the breeding season. So it could just be that they're moving around a lot more, they're more active, and that's why we're detecting them more. But I think these results are important because they kind of don't agree with the idea that monitoring colder months is necessarily better. You can see that we didn't detect any skunks during May, but we only had a couple cameras out for a week or two, so I would take that with a grain of salt. I don't think that really means anything. I think it's just a low sample size issue. These are our daily activity pattern results. The skunks were completely nocturnal with activity peaking in the early mornings before sunrise. And when we compared activity at the attractants to the control, none were significantly different, which suggests that using attractant does not bias daily temporal data, which is good. And in fact, Wild Boar carcass, which is the one that I would expect them to alter their activity at the most, was the most similar to the control. So from all of this, we can conclude that Wild Boar carcass is the most effective attractant. It's the only attractant to both increase detections and decrease latency to detection. It also likely increases repeat visits, and I think the skunks stick around longer at that attractant than they did at the others. We compared our detection results to that of the previous studies in our literature review, and with the Wild Boar carcass, our detections were higher or similar to that of all the other studies. However, using a large animal carcass is logistically challenging. They're not available everywhere. They're difficult to move. You can't always put them out if there's going to be a lot of people in that area, something like that. And so if that is true, sardines are also an effective attractant. However, they increase detections less than Wild Boar carcass did, and they didn't decrease latency to detection at all. We did use them as a scent lure, and there are some other studies that have used them as a bait. It's possible that they would be more effective as a bait since the skunks can actually eat them, and it seems to be more effective with the carcass. So that would be something that would be interesting to test. You would just have to replace them more often if they were going to be used as a bait because they would likely get eaten. And then the other important takeaway is that fatty acid tablets are just not effective for Eastern Spotted Skunks and shouldn't be used in future studies. And one other caveat is that climate and environment can really affect how effective attractants are. Scent travels farther on warmer, wetter air, but attractants also decay faster in these environments. So it's sort of a balancing act. And I think both these attractants that we tested and that long list of attractants that I had at the beginning of my presentation really need to be tested across the skunks range to try to figure out what's most effective in each area because that may vary. And then as far as the seasonal and temporal patterns go, our results don't really support the idea that monitoring in colder months is better. Most of our detections were actually in the warmer months, not the colder months of winter. However, there's the obvious caveat that we were not able to monitor during the summer just because of logistical challenges of working in Texas in the summer. And so we can't really comment on the larger seasonal pattern. But I think our results are enough to suggest that maybe this should be tested more. More people or more studies should be monitoring year-round and comparing those results and trying to figure out what the best time to monitor actually is. There was one study, Perry et al. 2018, that did incidentally capture 18 spotted skunks in the summer, which suggests that that may depend on location, what's going on that year, that sort of thing. So again, I just think that should be tested further. And then our daily activity pattern data basically shows that using attractant doesn't bias daily data at all. And so we can hopefully use that in, or we can keep using attractants in studies that look at temporal activity and not really be concerned about that. I would like to thank everyone who helped us with this project. Just Daly was a field tech who collected a great deal of data for us. Michael Ward and Kevin Cagle were both very helpful with logistical support. We had 2 reviewers that gave us some really good feedback on our paper and I think made it significantly better. And then of course our funding agencies, who without them we couldn't have done any of this. So again, thank you all so much. And with that, I can take any questions you have. This is my email address if anyone wants to get in touch with me after this. And I would like to say that the paper that this talk is based off of was recently accepted to the Journal of Wildlife Biology. I don't know exactly when that's going to be published, but keep an eye out for that because hopefully it will be soon.